Elevation drawings are the most important part of your AV system installation. Without considering these in advance, you risk additional cost, poor functionality, and frankly, an awful look. So elevations are a set of drawings used to communicate how you plan to install technology. They set out the hardware locations, fixing points, and requirements from other trades such as power sockets, data cables, and other routes for cables that need to be installed. As AV professionals, we look to do these as early as possible to avoid additional costs, ensure site efficiency, and to make sure that the wider construction programme is not impacted by late or incomplete instructions. In this video, I'll run through a typical elevation and highlight the information that we typically pass over to the rest of the team. Before we get started, make sure to like, subscribe, and hit the notification bell so you never miss a video. I'm the meeting room doctor. Let's open surgery. So the first image is kind of the end game. As AV professionals, we're aiming for a wall mount display which is correctly sized, but it's also mounted at the correct height so that people in the room can see the display and interact with it successfully. We'll also see below the display a video bar. So this is a part of the video conferencing system, and the bar includes a camera, microphone and speakers. And again, it's installed in an optimal position. Out of view, we've got cable routes for both the tabletop touch panel and the computer modules that are sat in the background and run the video conferencing software. What you see in this image are the enablement items that sit behind the visible audiovisual equipment. So you'll notice an area that's been marked out for wall reinforcement. This is to ensure that the wall is strong enough to hold the screen and the video conferencing equipment. We've got marked out cable routes, which means that you can route cables to wherever they're needed. And you've got a display mount that's suitably sized for the screen that's going on the wall, and also the installation environment as well. And then also on that image, we've got power and data. So this is to make sure that we've got enough power for all of the equipment that's going in there. Good coordination makes it possible to achieve good functionality with equipment perfectly placed and cables hidden out of sight. So what we have on screen now is an example of an elevation build out. It shows us stage by stage how we build out each of the sections, clearly labelled with accurate descriptions. And these items are then read by the construction teams and acted upon. So looking at the individual items, let's break these down. Let's first look at how we deal with wall reinforcement. So just as a bit of background, when offices are fit out, construction teams typically use plasterboard walls. They're quick, easy and cheap to put up. The construction of these walls is using typically a U-shaped, lightweight track that's fixed to the floor and the ceiling, and then 600mm joists are created. And this is a fixing point for plasterboard to be screwed to this frame. Inside the wall we have power, data, cable routes and sound insulation. Whilst plasterboard is fine to support lightweight items such as pictures and shelves, small shelving units, it may not be possible to hang heavy AV systems off that without further reinforcement. So let's remember that displays can be 20 kilos up to almost 100 kilos in weight, and other equipment may be 10 kilos or so. In most cases, we need to ask the construction teams to provide wall reinforcements, inserting plywood inside the wall to provide adequate fixing points and weight bearing capabilities. On the drawing, we indicate the minimum area of this wall reinforcement. A centre line in blue helps orientate the whole installation, providing a fixed reference point to all the trades. Somewhere to measure from, I guess, and it's typically the centre of the room, although it could be referenced against another point, like the centre of a meeting room table. Now let's look at AV cableways. So AV systems have a variety of different connectivity needs. So we have network cables, we have point-to-point Ethernet cables that connect proprietary pieces of equipment, and then we have other AV cables like HDMI cables. To route these to the various components, cable routes need to be established. And during the first fix, this is the part where they're putting the frame up, we need to tell the construction teams what is required and where. And this must be done before both sides of the plasterboard have been put in place, because we need to be able to run those cables. Containment also allows us to protect signals from high voltage cables, and also to provide easy future access should additional cables need to be run in as the system evolves over time. We would typically specify either a box trunking or a sort of circular Copex flexible tube, and both of them would have a draw wire inserted inside to allow us to be able to easily run cables to and from the start and end point. You'll notice here on the drawing that we've got access points below the floor and above the ceiling, as well as around the areas where the AV systems are going to be located. So as well as considering vertical routes, we should also consider horizontal routes, for example under suspended floors, especially where there's a permanent mounted flooring system going down in place and we don't have access. So again, we may choose to extend the Copex or trunking under the floor to be able to provide that sort of access. You'll note on the drawing that we want cable access grommets behind the major AV equipment, the display and the video bar. We've also asked for a hole to be cut in the floor so that we can freely run between the inside of the wall and the void underneath the suspended floor. Note on this drawing that we've referenced the centre line again, providing consistency to the previous drawing. So now let's look at power and data. So AV systems need mains power and other connectivity to function properly, and this needs to be coordinated. AV systems need mains power and other types of connectivity to function successfully. So we will consider the number of power, data and signal cables required, their location in reference to the centre line and also the distance from the floor. Our aim here is to hide the cables away, avoid bracket footprints so that we're not snagging between them, and provide sufficient connections so that everything has a place and everything is plugged in. And we must also not forget AV components located elsewhere. So consider cupboards, ceilings, items located under the table, just to make sure that they have sufficient connectivity to networks, connectivity to other AV systems, and also the mains power that they need. For complex installations, I generally create a spreadsheet breaking down in each room by device, showing what each of these items needs. So we would list mains power, network, point-to-point connections, specialist AV systems like HDMI and USB, any control system requirements, and then also fire alarm systems. Doing this in advance will also allow us to be able to allocate Cat6 patch leads, HDMI fly leads, USB fly leads, and also any power adapters that are needed. So the display mount position is very important. In most cases, displays are mounted 1200 millimeters from the floor, and this figure dictates the bracket position, but also the location of power, data and other cables that are needed to be run into the system. Importantly as well, it also provides a shadow from the display, where if necessary we can mount other AV related systems out of view. Professional brackets provide good quality setting out data, allowing integrators to accurately plot installations in advance, which is important. Different bracket styles and manufacturers will be set up differently, but on the drawings we have 3 common styles that are listed. The last image here shows the technology in place. So we've got the display screen mounted onto the wall securely at 1200 millimeters from the finished floor level. And this gives good visibility for the users. We've got power and signal cables which are hidden away. And of course the bracket has a secure fixing point behind the screen. The video bar is mounted onto the wall at 1000 millimeters from the finished floor level, providing effective audio and video pickup. The power and signal cables again are hidden, and it's securely fixed to the wall onto the reinforcements that we specified. Connections to the wider room have been established because the cable routes have been provided for our touchscreen controller, our LAN and WAN cables, content sharing, and any external microphone speakers or additional cameras. By doing this exercise early, it also forces us to consider cable lengths, just to check that they're within the tolerances of the dedicated cables. We consider the equipment size, so if we're mounting things in a credenza or behind a screen, we consider the size of those units to make sure that they will fit. And we also consider the cable entry into any bespoke made furniture so that that can be accommodated by the furniture manufacturers in advance of the furniture handing over. So who is responsible for AV elevations? Well, in reality, it's a collaboration between the client, the designers, construction teams and the AV integrators themselves. And the coordination is there to avoid clashes of other services and to avoid program delays. Ultimately, the client and the designers want the look and feel, the functionality. The construction teams want to know what they're building, where and when, and the AV integrators want a good base to install their equipment. And this can happen quite late on in the program. So back to my original statement, elevations being the most important part of your AV system installation. Well, we kind of think so. There are many things to consider when looking at your next meeting room upgrade. At Meeting Room Doctor, we know this and we want to help. Whilst our videos are helpful, sometimes you just want professional guidance dedicated to your project. Well, I'm pleased to introduce Meeting Room Doctor Surgery and Meeting Room Doctor on your team. Meeting Room Doctor Surgery provides professional AV consultancy for a fixed fee per room. This package includes a professional assessment of your display screen sizes using industry formulas and matched to the plans of your room. We conduct a comprehensive reverberance assessment to ensure the room doesn't echo and performs at its best. And if needed, we can recommend acoustic treatments too. We provide AV elevation templates, and these guide construction teams on the exact placement of hardware, services and cable routes, vital to ensure the correct performance and the highest quality look for your meeting room. We make hardware recommendations. This includes all elements: display screens, cameras, microphones, speakers, conferencing hardware, the whole solution. We can also recommend Meeting Room Doctor approved install contractors, should you not have one already. Lastly, our comprehensive companion guide gives a deep dive into AV technologies and helps you understand the theory behind our recommendations. Meeting Room Doctor on your team is more hands-on, and it's designed for companies refurbishing or relocating over a longer period of time. The clue's in the name really. On your team means that we become part of your team for the duration of your project. In addition to surgery items, we want to immerse ourselves into your project. We want to fully understand your objectives, and we want to meet your team and become part of your technology vision. Let us help you define what success looks like in your meeting rooms. And then to understand the plans, the usage, the budget requirements, and to recommend ultimately the technical solution that will meet this. We can even introduce you to our Meeting Room Doctor approved installers, or we can work with your existing partners. During the build, we often join weekly project calls and act as a bridge between internal teams and construction and technology people. A simple conversation can quickly keep a project on track, ensuring success and avoid costly variations. Upon completion, we can verify the installation just to check that it meets those success criteria that we set out before. And we can also recommend ongoing support, training and the documentation requirements to make sure that your system works for the long term. Be sure to check out the link in the description for more information. If you found this video useful, check out our other Fundamentals series videos where we cover a wide variety of meeting room technologies and what AV professionals consider when they're looking at meeting spaces. Thank you for watching. I really appreciate your support. Make sure to like, subscribe and hit that notification bell so you never miss a video. Let's all agree, every meeting room deserves to be doctor approved. But for now, I've got other patients waiting. Meeting Room Doctor out.